Okay, here we go, chapter 12, mathematical sequences and series and patterns and all kinds of stuff. You did most of this in Algebra 2. There are a few things in here that are a little bit more advanced, but almost all of this will be reviewed in some way or another. And don't worry about the objective part. We're looking at patterns and stuff and sequences. So a sequence is a pattern of numbers separated by a comma. Terms of a sequence. We use the same variable for every term in the sequence. How do we separate which ones they are? We use subscripts. A sub 1, A sub 2, A sub 3, A sub 4. So A sub 1 is the first one, A sub 2 is the second one, A sub 3 is the third one, and so on and so on. A sub 23 is the 23rd one in the sequence. I don't necessarily need to know the 22nd or the 24th. A sub n is the last one. A sub n minus 1 is the penultimate one, or the one before that. And you can count backwards. N minus 1, n minus 2 would be the one before this, n minus 3 would be the one before that, and so on. An arithmetic sequence is a sequence generated by a constant sum or difference. In other words, how do I get from one to the next? I add the same number or subtract the same number each time. We don't think about subtraction, we think about it in terms of adding a negative. So if I add the same number each time, either positive or negative, to get to the next number in the sequence, that is an arithmetic sequence. The number that we are adding every time is the common difference, and we use D for that. Geometric sequences are won by multiplying by the same number each time or dividing. Once again, we don't like to think about it as dividing. We think about it as multiplying by a fraction. So instead of dividing by 2, you want to think about it as multiplying by 1/2. The common ratio is what we're multiplying by each time. And that common ratio is R. We use D for difference, R for ratio. D is for arithmetic. R is for geometry. An explicit formula is a formula to find a particular number or particular spot that in that generation, A sub n. If I want to find the nth term, I plug in n into that formula. I don't need to know all the ones before to be able to find that one. I want to find the 100th term. I plug 100 into a particular formula. It spits out the 100th term without knowing the first 99. You can do that with arithmetic. You can do that with geometric. You can't do that with all sequences. If you're not arithmetic or geometric, you may or may not be able to do that. A recursive formula is one that will always work. A recursive formula says, hey, here is my first one. This is my first. And then it tells you how to find the next one, and how to find the next one, and how to find the next one. So if I have my first one, I can find the second. If I have the second, I can find the third. If I have the third, I can find the fourth. So if I want to find the nth term, I need to know the one before it. As long as I know the first, I can find all the rest of them. If I want to know the 44th, I need to know the 43rd. If I want to know the 43rd, I need to know the 42nd, and so on. With a recursive formula, you can't jump in the middle of a line. You must do all the ones before it to get there. Recursive formulas will work with arithmetic and geometric, but they really don't use them a whole lot for that. They're used for other types of sequences. Now, so if I have, here's a couple of formulas here. If I have a particular, these ones here are explicit formulas up on top. If I want to find the first n terms, this is what I do. I plug in n. So in this first one here, a sub 1 is equal to 1 minus 1 over 1 or 0. A sub 2 is 2 minus 1 over 2 or 1/2. A sub 3 is 3 minus 1 over 3 or 2/3. And you can pick up on the pattern. So my fourth term, a sub 4, would be 3/4, and a sub 5 would be 4/5. But you plug in the n, plug in whatever term you're looking for, and find the next one. So if I want the 100th term, it would be 100 minus 1 over 100, or 99 over 100. Okay? So the next sequence, B, C, B, B sub 1, B sub 2. If it's even, it's just that number. It's 1 over that if n is odd. So if n, it's n if n is even. It's 1 over n if n is odd. So B sub 1, 1 is odd, so I get 1 over 1, which is 1. B sub 2, 2 is even, n is even, so it is just that number. B sub 3 is 1 over 3 because 3 is odd. B sub 4 is 4 because 4 is even. B sub 5 is 1 over 5 because 5 is odd. Okay. And then we get down to the last one. This is a little bit more difficult, but it really is not that hard. You just plug in 1 for n, and 2 for n, and 3 for n, and so on, and figure out what you have. So, for example, if I'm looking for the first term, c sub 1, that's negative 1 to the 1 plus 1 power times 2 over 1. And that's what you do. N is 1, plug in 1 for n, plug in 1 for n, and then figure out what you get. So 1 plus 1, this is 2, so I have negative 1 to the 2 power, which is 1, times 2 over 1, which is 2, so c sub 1 is equal to 2. C sub 2 is negative 1 to the 2 plus 1 power over 2, because n is 2. So I have 2 plus 1, that's 3. Negative 1 to an odd power is negative 1. 2 divided by 2 is 1, so I get negative 1. C sub 3, negative 1 to the 3 plus 1 power, all over 2 over 3. 3 plus 1 is even. Negative 1 to an even power is 1, times 2/3. I get 2/3. I can do the same thing for C sub 4. And you get negative 1/2, and C sub 5, and you get positive 2/5. Okay, so that's how those are not recursive, those are explicit. I can just plug it in. If I want to find the 100th term, I plug in 100 for n, and I plug in 100 for n, and I figure it out. I don't need the previous terms to do this. Okay. Now these terms here are recursive. Being recursive, that means that I need to know the first one to be able to find the next one. So my first term, s sub 1, is 1. First term is 1. S sub 2, I take n times n minus 1. So what I do is I take, so n is 1, so n is 2, so I have 2 times the 1 before. N minus 1 is the 1 before. So I have 2 times 1, which is 2. S sub 3 is 3 times 2, which is 6. S sub 4 is 4 times 6, because I take it times the 1 before. I take n times the 1 before. 4 times 6 is 24. So the fifth term, S sub 5, is 5 times 24, or 120. These are explicit, these are recursive formulas. I can't find one unless I know the one before it, because this is the term before. I have to know the term before. This one's a little unique because I not only have, I'm given the first term, I've given the second term, and in order to find the next term, I need the 2 before. This is the 1 before the nth term, this is 2 before the nth term. So, u sub 1 is 1, u sub 2 is also 1 because those are given to me. Those are given. So if I want to find the third term, so the third term is, so this would be u sub 3. This would be 3 minus 2 or u sub 1. 3 minus 1 or u sub 2. So I have 1 plus 1 or 2. So u sub 4, I take the 2 before that and add them together. 2 plus 1 is 3. U sub 5 is 3 plus 2, which is 5. So I have 1, 1, 2, 3, 5. And Smart. Some of you out there may already know what the next number is. It's 8, 13. And some of you may know what this sequence is. This is the Fibonacci sequence. In order to find a number, what do? You add the 2 before it. Okay. Determine if the following are arithmetic or geometric. If arithmetic, geometric, or neither, and D or R if it is appropriate. So, am I getting to the next number? How am I getting to the next number? Am I adding the same number? Am I multiplying by the same number? What am I doing to get from one to the other? So if I look at this first sequence here, to get from 2 to 6, 2 to -6, and -6 to 18. Well, I have a couple of choices. If it's arithmetic, I would be adding the same number each time. So to go from 2 to -6, I would have to add -8. If I add -8 to 6, am I going to get 18? No. So it's not arithmetic because I'm not going to add the same number each time. And here's the hint. If it changes sign each time, it will not be arithmetic. The best it could be would be geometric. How do I get from 2 to -6 by multiplying? I multiply times -3. If I multiply -6 times, if I take -6 times -3, do I get 18? Yes. If I take 18 times -3, do I get -54? Yes. So this is geometric. And my R is -3 because I multiply by -3 each time. Now this next one's kind of confusing, a little bit harder, but here's what you want to do is say, okay, I've got a bunch of fractions. All the fractions all have the same denominator. Anything that is not a fraction over that denominator, make it a fraction over that denominator. So rewrite 3 as 6/2, rewrite 2 as 4/2, rewrite 1 as 2/2. So if I go from 6/2 to 5/2 to 4/2 to 3/2 to 2/2 to 1/2, am I adding or subtracting the same number each time? I am. This is arithmetic. And the thing that I'm adding each time is -1/2. 6 plus -1/2 is 5/2. 5 plus -1/2 is 4/2. And so on. So my next number would be 0. And the number after that would be -1/2. And the number after that would be -2/2 or -1, and so on. And then I look at this last one. How do I get from 9 to 10? By adding, I add 1. If I add 1 to 10, do I get 12? No, so it's not arithmetic. How do I get from 9 to 10? By multiplying. I multiply by 10/9. If I take 10 times 10/9, do I get 12? No, so this is neither arithmetic or geometric because I can't add the same number, or I can't add or subtract the same number, or multiply or divide by the same number. So, determine if the following sequence are arithmetic, geometric, or neither, and confirm by testing pairs. Here's what you do by testing pairs. So, take an educated guess first. So I look at this first one, 3, -1, -5, and I go, all right, how do I get from 3 to -1, -1 to -5? It appears that I would be subtracting 4 each time. Is that what is happening? Here's how you find out. You take a term, subtract the previous term. -1 minus 3, what do I get? I get -4. Take the next one, -5 minus -1, and I get -4. Take -9 minus -5, and I get -4. If I subtract the previous term and I get the same thing every time, it's arithmetic. And the thing that I'm getting each time is my difference, my D. Okay. This one changes sign every time, so it's obviously not going to be arithmetic. It might be geometric. You do the same sort of thing. I can't add or subtract every time, so instead of subtracting, I divide. So I take term divided by the previous term. -9 divided by 3, and I get -3. I take 27 divided by -3, and I get, -9, and I get -3. I take -81 divided by 27, and I get -3. I get the same thing each time by dividing. That means this is geometric. And R is -3. So let's take a look at our last one here. So if I go from 8 to 4, I would add 4. From 4 to 2, I would be adding 2. So it is not arithmetic. It might be geometric. Here's what I want to do. I want to test it out. Take 1 divided by the previous one. 4 divided by 8, that's 1/2. 2 divided by 4, that's 1/2. Ooh, looks like I'm on a pattern. Great. Hey, it's geometric. It's 1/2. Well, let's keep going. So we take 1/2 divided by 2, and we get 1/4. Uh-oh. It's not the same thing every time. This is neither geometric or arithmetic. Okay, factorials. Oh, I love factorials. Factorials, a number followed by an exclamation mark. That does not mean that we say it really loud or with emphasis. When we have 4 factorial, that is not 4. That is not what that means. You do not say it with emphasis or enthusiasm. That is not what it means when you have an exclamation mark. And you have factorial on your calculators. Find the factorial. It's usually under probability, but if you see a number n followed by an exclamation mark, that is factorial. And what that means is you take it times the number in front, times the number in front, times the number in front until you get down to 0. So 4 factorial is, once again, not 4. It's 4 times 3 times 2 times 1. You take it times that number times every integer down so you get to 1. And when you do that, 4 factorial is 24. Now, 1 factorial is b1. N factorial is n times n minus 1 times n minus 2 times ... times 2 times 3 times 1 all the way down. That's what you get for that. 0 factorial, by definition, because 0 doesn't work here, 0 factorial is 1. You have to have the definition for that because factorial are used in combinations and permutations. 0 factorial, by definition, is 1. Okay. Summation notation. We needed summation notation before. Summation notation is where you use epsilon. That's where epsilon comes in. This means I'm adding them all together. I want to add all together. I'm going to take a sub n, or a sub n or a sub k, you can use anywhere, from n equals 1, because 1 is what I'm starting with, to wherever I want to end, in this case, n. I don't like using the same variables everywhere, but that's kind of what I'm stuck with at this point. Okay. That's what summation notation is I'm adding them all together. Now, you'll notice this doesn't have the k equals 1 at the bottom and the 10 at top. That is because often on certain equation editors, you can't write them on the top and the bottom. It does it like this, but that means the same thing. Equals 1 here and the 10 there, that's where they mainly mean the top and bottom. What does this mean? This is my formula, and I'm adding together. I'm taking k from 1 and 2 and 3 and 4 all the way up to 10. So I'm having 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9 plus 1 over 10. That's what summation notation is. Okay? So, same thing on this one here. Let's rewrite this as a sum. I want to add all of these together. So I'm going to add them all together. That's what that means. And what's my formula here? I have 1 squared, 2 squared, 3 squared, 9 squared. So this would be 4 squared, 5 squared. So what am I doing? I'm taking the nth number and I'm squaring it. And going from n equals, what's the first number I have? I have 1, and my last number is 9. So I'm going from 1 to 9. I'm squaring each one of them. 1 squared plus 2 squared plus 3 squared and so on, all the way up to 9 squared. I want to add them all together. So find the sum. So what do? You take what I wrote up above, and you add them all together. Use your calculator, please. Don't do it by hand. You really, really don't want to do it by hand. And you get 7,381 over 2,520. This is what you get when you add them all together. Nice, short, sweet lesson.